We just looked at sequences and series. Now we're going to look at a special sequence called an arithmetic sequence. So an arithmetic sequence is where you have a term minus the term right before it is always going to give us the same constant D. We call it D, the common difference. So in front of us, we have the definition of an arithmetic sequence stated a little differently than what I just stated. When the difference between the successive terms of a sequence is constant, the sequence is called arithmetic. So definition, an arithmetic sequence is defined recursively as a sub 1, which is equal to a, and a sub n minus a sub n minus 1 is d. So remember, I just stated that if we could take a term minus the term right before it, we get some constant d. So this is what I was stating. A term, a sub n, minus the term right before it, a sub n minus 1, is some constant d. Or where a sub 1 is a and d are all real numbers, the number a is the first term. Of the sequence, and the number d is called the common difference. So we have an example in front of us that show the sequence is arithmetic, list the first term and the common difference. So for part A, we have 4, 2, 0, negative 2. So we want to show that this is arithmetic. So showing that it's arithmetic says that if we take a term minus the term right before, we should always get the same constant d. So if I looked at the second term minus the first term, this would be 2 minus 4, which is negative 2. If I looked at the third term minus the term right before it, the second term, I would have 0 minus 2, which is negative 2. As long as these numbers are the same, then we have an arithmetic sequence. So now looking at the fourth term minus the third term of the sequence, well, the fourth term is negative 2, and the third term is 0. So negative 2 minus 0, this is also negative 2. So we showed that it was arithmetic. We saw that the common difference, d in this case, was equal to negative 2. And we want to know what is the first term. Well, looking at this sequence, I can see the list. My first term, a, or I usually call it a sub 1, is equal to 4. So our next example, we're given that our sequence, S sub n, is equal to 4n minus 1. So to show that this is arithmetic, I need to show that the term S sub n minus the term right before it, S sub n minus 1, is always going to equal to some constant d. We're given the nth term, which is 4n minus 1, minus the term right before it. So this would be 4 times, well, the term right before n is n minus 1. So 4 times n minus 1, then minus 1. So let's simplify this and show that we get some constant back. And if we get a constant back, then we know it's arithmetic. If we simplify this and we still have n in terms of our expression, then it's not going to be arithmetic. So I notice here, the first parentheses I don't need, I can just drop them. So I have 4n minus 1. Let's distribute our -4 inside the second parentheses. So we have -4 times n is -4n. -4 times -1 gives us +4, and then we have -1. Combining like terms, I have 4n minus 4n, those cancels with each other. Then I have -1 plus 4, which is 3, and then 3 minus 1, which is 2. So we get our common difference here is 2. To find the first term of our sequence, well, we want to find s of 1. So we want to plug in 1 for n. So we get 4 times 1, which is 4 minus 1, which is 3. So the first term of that sequence s of n would be 3, with a common difference of 2. So for the sequence t sub n, where t sub n is equal to 2 minus 3n, we want to show that this is arithmetic. So we want to show that if we look at t to the n minus the term right before, t sub n minus 1, we get some common difference d. Well, t sub n is this 2 minus 3n minus t sub n minus 1. So I'm going in here, wherever I saw an n, I'm going to plug in n minus 1. Need parentheses around this whole thing, so I have 2 minus 3 times n, but in this case, n minus 1. So let's simplify this. We have 2 minus 3n minus, let's distribute our -3 inside this parentheses. So we have parentheses 2, -3 times n is -3n, -3 times -1 gives us +3. So we have 2 minus 3n minus, combining like terms inside our parentheses, we have 2 plus 3, which is 5 minus 3n. Let's distribute this negative sign inside the parentheses. So we have 2 minus 3n minus 5 plus 3n. Combining like terms, I have a -3n plus a 3n, so those cancel. And then I have a 2 minus a 5, which gives me back -3. So we just found that our constant common difference d is -3. And to find our first term, t sub 1, let's go back in and plug in 1 for n. So I have 2 minus 3 times 1. Well, 3 times 1 is 3, so 2 minus 3 gives me -1. So the first term of that sequence is -1. Okay, so we saw a couple of things for our formulas. Let's move this over a little bit. So we saw that, first of all, if we take a term minus the term right before, and it's arithmetic, we must get some common difference d. So this is one formula for an arithmetic sequence. But notice if I added a sub n minus 1, that says that a sub n is equal to the term right before it, a sub n minus 1, plus our common difference, d. So here is another formula for an arithmetic sequence. We're going to derive one more formula for an arithmetic sequence. So these are in your notes over here. I'm actually gonna just derive it myself and not just look at all those words. Okay, so where was I? So I know my first term, A, is equal to my first term. I know my second term is equal to my first term, A sub 1 plus D. Just using the second formula. Then my third term is equal to the term right before it, which is A sub 2 plus D. But let's go back and do some substitution. We know what A sub 2 is. We can rewrite A sub 2 as A sub 1 plus D. So I have that A sub 2, A sub 1 plus D, plus this other D. So my third term I can write as A sub 1 plus D is 2D. I'm going to box these because we're going to use them. So going on in this format, I can say, well, A sub 4, I know by the definition, this is equal to the term right before, which would be A sub 3 plus that common difference D. But we know what A sub 3 is from above. A sub 3 is this A sub 1 plus 2D. So let's replace this A sub 3 using substitution with A sub 1 plus 2D plus D. So doing that, I get A sub 4 is equal to the first term, A sub 1 plus 3D. We need one more. A sub 5, if it's arithmetic, it has to equal the term right before, A sub 4 plus the common difference D. But we're given what A sub 4 is. So let's go back and rewrite what A sub 4 is. By substitution is the same thing as A sub 1 plus 3D plus this D. So A sub 1, and then I had 3D plus D gives me plus 4D. I don't know if you notice a pattern here. So A sub 1 is A sub 1. A sub 2 is A sub 1 plus D. A sub 3 is A sub 1 plus 2D. A sub 4 is A sub 1 plus 3D. A sub 5 is A sub 1 plus 4D. So A sub n is going to equal the first term, A sub 1, plus, notice this number in front of the D. So 4D, that was when my term was 5. 3D, that was when my term was 4. 2D, that was when my term was 3. And then I have 1D, that was when my term was 2. And so notice that that is 1 less than the term we're at. So this is going to be n minus 1 all times D. So this is the third formula that we're going to be using to help us when we're trying to find the nth term, or the formula for the nth term of a sequence. So that's one. Let me just write the other ones in front of us. We know that taking a term minus the term right before, A sub n minus 1, would equal the common difference D. And we know that the nth term is equal to the term right before, A sub n minus 1, plus our common difference D. So those are all formulas for your arithmetic sequences. So as long as you know the definition, you can get these last two that I wrote out. And then we can derive really quickly, if you forgot, that other formula, a sub n equals a sub 1 plus n minus 1 times d. So we have an example in front of us that says the sixth term of an arithmetic sequence is 26, and the 19th term is 78. We want to find the first term and the common difference. We want to find the recursive formula for the sequence, and we want to find the nth term of the sequence. So let's go back to what they gave us. They said that the sixth term of the arithmetic sequence is 26. So I know that a sub n is equal to the first term plus n minus 1 times d. Well, it gave me the sixth term. So a sub 6 is equal to the first term, a sub 1, plus n minus 1. So in this case, 6 minus 1 times d. But a sub 6, I also know is 26. So I know 26 is equal to the first term, a sub 1, plus 6 minus 1, which is 5, times d. So I have one equation here with two unknowns. Let's go back and let's pull out some more information. So here it tells me that the 19th term is 78. So again, by knowing that this is arithmetic, I know a sub n, or a sub the 19th term, is equal to the first term, a sub 1, plus n minus 1. So 19 minus 1 is going to be 18 times d. But a sub 19, the 19th term is 78. So we have 78 equals the first term, a sub 1, plus 18d. So what they gave us, we came up with two equations, two unknowns. So we have a system here. These are linear equations. We can go and we can use our substitution method. We can use our elimination method, or we learned about matrices. We can use matrices to help us solve the system of equations. I know that if I multiply one equation by -1 and sum it to the other equation, my a sub 1 term would fall out and I could figure out what d is. So let's multiply the first equation we found by -1. So if I did that, I have -1 times 26, that's -26, is equal to -1 times a sub 1, so that's negative a sub 1, and -1 times 5d, that gives me minus 5d. So if I sum it with the second equation, so 78 plus a -26, that gives me positive 52 equals a sub 1 minus a sub 1 cancels. And then I have 18d minus 5d, which gives me 13d. Get d by itself, we can divide both sides by 13. So we get that d here is equal to 52 divided by 13 is 4. So we get our common difference, d is 4, and we want to find the first term. Well, let's go back to our formula. A sub n is equal to the first term. Actually, no, let's go back to one of the equations we know. So use one of the equations that we have. So how about this one? We know that 26 do this over here. We know that 26 is equal to the first term, a sub 1, plus 5 times d. Well, we just found that d was 4. So let's go back in and do substitution. So we have 26 equals the first term, a sub 1, plus 5 times d, but d we found was 4. So we have 26 equals the first term, a sub 1, plus 5 times 4, which is 20. Get a sub 1 by itself, we could subtract 20 on both sides. We get a sub 1 is 6. So we found our first term of the sequence, and we found our common difference d. So the first term of our sequence, a sub 1, we found was 6, and the common difference d we found was 4. So the next part of that example says, give the recursive formula for the sequence. So a recursive formula deals with terms previously. So we know that, as this is arithmetic, if I take a term plus the term right before, or equals the term right before plus d. So we know that a sub 1 is equal to the term right before, a sub n minus 1, plus d, but d in this case is 4. So this would be a recursive formula for that arithmetic sequence. And then they want to know, what is the nth term of that sequence? Well, another way to write this, where it's not recursive, we want to use this a sub n equals the first term plus n minus 1 times d. So a sub n is equal to the first term. First term was 6. So 6 plus n minus 1, put parentheses around it, n minus 1, times d. And d we found was 4. We can leave it like that, or we can simplify. So we have 6 plus, let's distribute our 4. We have 4n minus 4. So a sub n is equal to, combining like terms, 6 minus 4, which is 2, plus 4n. So with this formula, we can find any term of the sequence. So if I asked you to find the 100th term, of the sequence, it would be much easier, instead of finding the 99th term and then adding 4 to it. So I don't want to find all 99 terms or 98 terms. I could go in here, and I know that a sub 100 is equal to 2 plus 4 times n, but in this case, n is 100. So the 100th term is 2 plus 400, or 402. So we have some statements in front of us. It says, now that we know the formula for an arithmetic sequence, let's look at how to find the sum of the first n terms of an arithmetic sequence. So we have a theorem, the sum of the first n terms of an arithmetic sequence. So suppose the set a sub n is an arithmetic sequence whose first term is a sub 1 and has a common difference d. The sum s sub n of the first n terms of a sub n, our arithmetic sequence, may be found in 2 ways. So this is saying, remember summation, we're looking at the first term all the way up to the nth term and summing all those together. So s sub n is equal to a sub 1 plus a sub 2 plus a sub 3 dot 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 plus a sub n. So that could be tedious if you have lots of terms that you have to add and would have to find. And so there's another formula that we could use. So S of n, this is equal to n divided by 2. This is all times the quantity 2a sub 1 plus n minus 1. And minus 1 is in parentheses, all times d. Which, if we go through and we simplify, is the same thing as n divided by 2, that times the quantity of the first term plus the nth term, a sub 1 plus a sub n. So your book wrote it. This is how I normally write it. N times a sub 1 plus a sub n in the numerator, all divided by 2. Same thing. Let's look at an example where we're finding the summation of an arithmetic sequence. And so first find the first n terms of the arithmetic sequence. Where we have 4n plus 2. So find the sum of the first n terms. Of the arithmetic sequence. So I'm looking at the summation, k equals 1 to n of 4 times k plus 2. Well, if I look at this, my first term is a 4 times k. K is 1 plus 2. So 4 plus 2 gives me 6. If I look at my nth term, this is equal to 4 times n plus 2. Which is equal to 4n plus 2. So I know my summation is equal to n, all times my first term. My first term, though, I got was 6, plus my nth term. My nth term I found to be 4n plus 2, all divided by 2. So simplify, you have n all times, inside the parentheses, 6 plus 2 is 8, plus 4n, all over 2. So I have 8n plus 4n squared divided by 2. I could divide each term by 2. So this is 4n plus 2n squared. So if I summed the first n terms, I would get 4n plus 2n squared. So part B says find the sum of the first, or find the sum of 52 plus 57 plus 62 plus 67 plus plus 122. Okay, so actually, if you look at this, the formula says we need to know what the first term is, and we need to know what the last term is. I know my first term, a sub 1, is 52. I know my last term, a sub n, is 122. I need to know what n is, though. I need to know how many terms I'm summing. So we want to use our information to figure out what n is. And if we know what n is, then we can just use this formula. Well, let's go back to, I know that a sub n right here is 122. So I know that 122 is equal to the first term plus n minus 1 times d. So I also know 122 is equal to the first term, but looking at this, we found that the first term was 52 plus n minus 1 times d. Well, let's see if we could figure out what d is. If this is arithmetic, which it said it was, then it's the same number that we're adding from the previous term to get to the next term. So 52 to 57. 57 minus 52 is 5, so I'm summing 5. Am I summing 5 to get from 57 to 62? I am. From 62 to 67, I'm also summing 5. So I can see here that my common difference, d, is equal to 5. So enough information to figure out what term is that nth term of that summation. So let's solve that equation. We have 122 is equal to 52 plus, let's distribute our 5. So we have 5n minus 5. So 122 is equal to 52 minus 5 is 47 plus 5n. Subtract 47 on both sides of the equation. So 75 is equal to 5n. Divide both sides by 5. I get that n is equal to 15. So for that summation, I have n, which is 15, all times my first term, 52, plus my last term, which was 122, all divided by 2. So we have 15 all times 52 plus 122, that's 174 divided by 2. Well, 2 goes into itself once, 2 goes into 174, 87 times, and then I have 87 times 15. Which is equal to 15 times 87 gives us back 1,305. So one last example of an arithmetic sequence or series is the first row of seats in a quarter stadium section has 20 seats. There are 40 rows in this section, with each row having 2 more seats than the row in front. How many seats are in that section of the stadium? Okay, so let's go back. We know that the first row of seats and that corner stadium has 20. So maybe let's call A sub 1 20. There's 20 seats. I know that there are 40 rows. I know that I'm counting how many seats there are. And so I know that I'm looking at the summation from k equals 1. There's 40 rows, so I'm going to sum how many seats are in each row. And then I need to see if I can figure out what the formula is. Well, I know that this is arithmetic. I know what my first term is. It's 20 plus n minus 1 times d. Well, I know what d is because I'm just adding 2 more seats to each row. So I know that my second row is going to have 20 plus 2, or 22. My third row is going to have 22 plus 2, which is 24. So I know my d value here is 2. So I have what a sub k is, or a sub n. This is equal to, and this should be a k here, but a sub n is equal to the first term plus n minus 1 times d. So a sub n is equal to the first term, which we were given was 20, plus n minus 1 times d, which we just said was 2. Let's simplify this. So I know a sub n is equal to 20 plus 2n minus 2, or a sub n is equal to 18 plus 2n. So for the formula, I need to know what the last row, how many seats are in the last row. So I can look at a sub 40. This is going to be 18 plus 2 times 40. Which gives me 18 plus 2 times 40 is 80. 18 plus 80 is 98. So the summation is equal to n. N is 40. All times the first term, which was 20, plus the last term, which is 98 seats, all over 2. So let's simplify. 2 goes into 20 or 40 20 times. So I have 20 times, adding what's inside my parentheses, I have 20 plus 98, which is 118. Which gives me 2,360 seats in that section of the stadium. Okay, so next time we'll look at geometric sequences in series. So another important sequence. And that will be the last section of this course.